Hey, hi. In this video, I'm going to show you how to host a scalable web service on Amazon ECS, that is of Fargate version, with using DocumentDB as a backend database and ElastiCache as a cache service here. So as you see in this PPT, this PPT depicts my demo. Here I'm going to show you that how this setup is been set at my AWS account with using ECS Fargate service. So here the architecture is something like this. So here we will have a VPC. In that VPC, we're going to dynamically create the required subnets. In that subnet, we're going to host Amazon ECS service of type Fargate. And in that cluster, we're going to create required services which actually host our web service. Yeah, and then here in this service, we're going to deploy an example application that is nothing but Node.js application, very basic Node.js application. And this Node.js application has its own backend, that is DocumentDB. So DocumentDB is nothing but it's scalable NoSQL database, and then we're gonna have the ElastiCache. So here ElastiCache DB we're gonna use it as for our caching purpose. Yeah. So in front of these, we will have the Fargate service exposed over Elastic Load Balancer. And on top of this VPC, we will have the internet gateway so that Elastic Load Balancer can communicate to the internet. Yeah, nothing but the clients like coming from the from the clients like Windows, or it could be anything, or the clients like mobile phone who accesses this endpoint, that is Elastic Load Balancer, should be able to served by the the service that is hosted on ECS. Okay, so here this video is kind of from scratch to end, and here I'm going to show you how we can set up this infrastructure with using Terraform as infrastructure as a code. And then I'm going to walk you through the the how to convert the source code that we have, nothing but an application source code, how we can wrap it as a Docker image, and we use that Docker image to host it on Amazon ECS as a as a container service here. All right, so this is going to be a complete from scratch to end, nothing but from zero to basically expert level walkthrough of how to create a scalable service on ECS Fargate with using DocumentDB and ElastiCache. Okay, so stay tight. Here I'm going to walk you through the complete infrastructure as a code, CI/CD pipeline definitions, how to deploy that, what are all the steps you need to follow one after the other, and finally we see that the scalable web service is giving us a response. Yeah. All right, so with that option, what I do is I'm going to take you to the my AWS account. So this is my AWS account. Here I have already provisioned the required infrastructure, but no worries, I'm going to walk you through the complete source code, and we're going to see how to deploy this infrastructure in the AWS, how to deploy our application onto this this particular infrastructure, that is ECS, and then we're going to see how does the service responses. Yeah. All right, so I have a repository. So basically for this demo purpose, I have created a repository called AWS ECS Web Services. Okay, so in this repository, I have the folder structure meant for multiple purpose. Okay, so here we have a source code for application purpose. We have a source code that is containing infrastructure as a code for deploying the infrastructure required to host this container services. Yeah, that is nothing but host this application as a container application on the ECS cluster. And we also have the the CI/CD workflow being defined with using GitHub Actions CI/CD pipeline here. Yeah. All right. So these are the basically three main parts. What I do is I have cloned this repository in my VS Code. I'm going to walk you through the source code one by one. So here we will focus more on how do I how do I define the infrastructure as a code in Terraform. Then how I'm invoking that infrastructure so that the infrastructure is been the constructed on the AWS, and then how I'm wrapping this web application, that is Node.js web application, as a Docker image, and then how does I'm using that Docker image. Okay, here we have used Docker Hub basically. So I'm going to show you that how we can wrapping this application as a Docker image and putting the Docker image into the Docker Hub, and from there how I am referencing in the ECS. All right, so these are basically very very important point. This is basically a full stack application walkthrough, I can say. Okay, so without being late, I'm going to take you to my VS Code. So this is my VS Code basically. This is the an ID. I have already cloned this repository. So this is my repository. So no worries. I'm going to give the link of this repository in this video's description. You can find the source code of this same from my video's description and try to do the same thing from your side as well. So here we will walk through the code now. So what I do is, so as you see here, whatever we have seen in the source code in the GitHub, that's the same thing we have cloned it here, and currently I'm in main branch. I have only one branch for now, so I'm going to explain the infrastructure. How did I create it with using the simple branch? Yeah, single branch here. So first one, let's walk through the basically our infrastructure, right? So if I go back to my diagram, so what is my infrastructure here? We are using the VPC. We are constructing that VPC into a subnets. Into that VPC, we are creating the ECS cluster. In the ECS cluster, we are deploying a service that is basically creating a Fargate task. Yeah, and that service is being exposed over an ingress, or generally called as an elastic load balancer. And that load balancer you can access as a client outside. Whereas the backend of this application is nothing but we are using DocumentDB, that is a specialization, and then ElastiCache. Okay, so let me see how I'm constructing these infrastructure in Terraform and how is that is been provisioned in the AWS account. So for that case, we will first walk through the folder called DevOps. Yeah, in this one we go to the Terraform. So Terraform, as the name says, here I'm using Terraform as infrastructure as a code to spin up my infrastructure. So as you see here underneath the folder, we have a folders like we have a Terraform files like database.tf, main.tf, output.tf, provider.tf, right? Security group, variables, and VPC. Okay, so basically, so we have a three. Basically, we have a so basically we have four infrastructure defining Terraform file. That is database.tf file, main.tf, security group.tf, VPC.tf. Basically four, and the other files, that is variable.tf file, provider.tf file, and output.tf file is nothing but the supporting file needed for Terraform to work. Let's first walk through from the the initiation, right? So we need to have a variables in this folder. As you know, the Terraform invocation happens in the context of present working directory, in the sense whatever the file that you keep it in the present working directory, the Terraform executor will identify files ending with .tf and try to compile the the definition that you have defined in the Terraform, and it does its job. Yeah, so here we are seeing variables.tf file. As the name says, variable.tf file, it contains the variables. Here I have a variable called AWS region because I am creating my infrastructure in US West 2. So this is my AWS region. And then, as I said, we are using the DocumentDB. So we have basic DocumentDB is nothing but a cloud version of MongoDB. MongoDB is nothing but an open source NoSQL database, right? So that that is being managed by AWS with lots of other flexible features added on top of that, and that version generally called as a DocumentDB, which is just basically a MongoDB version. So here we are actually creating a master user called default Mongo user, and the password of that Mongo user is I'm just creating it and storing it in a variable option. But in your case, you can make it as serialized from the the GitHub secret as well, which I'm going to show you ahead as well. Then here we are actually consuming the Docker image. So here for this case, for this demo purpose, I have created basically Docker Hub. So I have an account in Docker Hub. From the Docker Hub, my username is this is my username. From this username, I have created a token that is nothing but Docker token. So basically, with using the Docker user ID and Docker token, I'm using these two basically credentials to interact from the GitHub Actions with the Docker Hub and pushing the image. So basically, this account is private account, right? So I'm pushing this image into this particular my Docker Hub account. Okay. So this is basic. That's the reason I have predefined what will be my repository in the Docker Hub. So our repository name is nothing but something like this, that is ECS web app, right? And for now, consider that we have a repository something like that. Okay, so if you are fresher to the Docker Hub account and say that you have a Docker Hub account, so you can go to the create repository and try to create a repository name something like blah blah, and give it the visibility equal to public, because this is a demo, so that's the reason I have given as a public. But in your case, you can make it as a private as well. Yeah. So with this option, click on a create. Basically, it will create a repository. something like ECS web app. Okay, so this is the repository where we actually gonna host our application image here, that is container image here. Yeah, and you see that the reference of that image is being shown here. That is what I have copied in the variable, right? You see here. All right, and then next one, that is Redis port. Okay, so I'm just using the Redis as a cache providing service here. That is nothing but in memory cache service. And MongoDB port is, this is our MongoDB port, and this is the Docker port. Okay, so these are all the variables, and while I walk through this Terraform file, I'm gonna explain the supporting infrastructure, right? So here we have a many moving parts here. Okay, so one is we have a Docker hub, we have a TFC for storing the state file, we have a AWS for hosting the infrastructure. Yeah, we have a GitHub Actions for CI/CD, right? We have a many services, many moving parts actually deploying the infrastructure and hosting an application for us. Yeah, and then now we go to the next option, that is provider.tfl. As the name says, provider.tfl, so this is file where you declare the providers of the Terraform. So in my case, we are using the AWS because that's the way we are actually creating the infrastructure. So our provider is AWS, and this is the format of HashiCorp AWS provider version. And then in the backend, as I said, we are using Terraform Cloud as a backend state, backend workspace for storing the state of the infrastructure. So this is my the organization in the app.terraform.io subscription, and then in that one I'm using the workspace. Okay, I'm going to show you this as well. If I go to the app.terraform.io, so if I go to the, again, let me go to the basically to this site. So once you click on this app.terraform.io, you need to log in into account and choose your organization. So in my case, my organization is cloudquicklabs, which is my channel name. In this one, I have created basically workspace. In my previous video, I have shown you many times how to create the workspace, how to configure the workspace so that it can do a CI/CD with the GitHub Actions pertaining to AWS. Yeah. So for that case, we have created a workspace. I'm going to quickly show you that how to create a workspace as well. So click on new, create a workspace. Workspace, which is basically the CLI driven. So click on this one and give the workspace name like this. Project let it be default, and click on create. Yeah, so in my case I'm canceling. In your case, you will be creating it. So once your workspace like AWS ECS in my case is done, you're going to go to the variables. In the variables, you're going to see the workspace variable. In the workspace variable, you need to add two keys, that is AWS access key ID, AWS secret access key ID. Nothing but, this is nothing but an user who has access on ECS, DocumentDB, and ElastiCache service. Okay, so and also other relevant service access has to be provided that I am user, and give it as a programmatic access, and the access key ID secret value you can keep it here, and those categories should be environmental. Okay, so how to create is that click on add variable, and here you need to choose the option that is environmental variable. Give the key, give the key name like I have shown here, that is AWS underscore access underscore key underscore. Okay, so remember this is case sensitive, so keep it as same as it is shown here, and give your I am user the access key and secret value here. So respectively you need to do it twice so that you add these two variables. Okay, so with this option, your workspace is ready to be added as a backend information in the provider.tf file. So we go back to the provider.tf file. So here, after doing that, I added my workspace here, and then I added the cloudquicklabs. Okay, so not only that, you need to also have a token of your user ID, right? So this is my user, and this user has for this user you need to create a token, and that token is needed as a secret in the GitHub Actions. So for that case, I did something like this. Go to the account settings of the user, go to the tokens here, and then you can create a required token. Okay, so I have created ECS Labs token, and that token I have added as a secret in the GitHub Actions, which I'm going to show you as I walk through the the GitHub Actions ahead. Okay, so these are all the configurations we manage on the TFC, that is Terraform Cloud. Okay, all right, so now let's continue where we stopped in the code walkthrough, that is Terraform code walkthrough. Okay, so then here we have a provider that is nothing but reason, that is US West 2. Okay, so with that, now let's go to the output. So output is very interesting one. Basically, once everything goes good, for the first time, generally it will output the values that you are referencing here. Okay, so here first one we are referencing the region to be output. We want the Redis connection information to be given as output. We want the Redis connection port number. We want the the MongoDB connection string. Okay, so we need both. Basically, we need three information, that is Redis connection address, nothing but FQDN of Redis cache endpoint, and then MongoDB connection URL. So that should be in this format, and the format name is nothing but MongoDB small letter / username password. Okay, and then this is your this is basically DocumentDB Elastic Cluster endpoint, that is FQDN at the rate and nothing but question mark SSL equal to true, right try retry writes equal to false. Okay, basically you need to construct the output the MongoDB connection string something like this. Okay, and then we have a ALB, that is nothing but, as I said, we are exposing the service over the Elastic Load Balancer. That Elastic Load Balancer URL will be available here. So that is our output. Okay, so basically I have walked through the prerequisite files of this infrastructure. Now let's go one by one. Okay, so first let me go to the next step, that is nothing but main.tf file. As the name says, main.tf file, this is the file which actually creates the main resource of the infrastructure. Yeah, let's see what are those. So here we are actually creating an ECS cluster, you see that, and this cluster is being used as a reference down the line to create the further resources of the the ECS cluster. One is, so you have a cluster defined, resource defined, that resource need to have the, so basically that resource need to have the capacity. So we are declaring the capacity something like this, that is capacity provider. So underneath the ECS you have two options. One, you can opt in the ECS as a Fargate. Fargate is a nothing but kind of a the kind of a service option from ECS, which actually where it provides a cluster for you, where you don't need to manage the nodes, but you just deploy your containers or the pods on that cluster. The ECS automatically identifies the basically the software runtime requirement, basically the resources needed on the worker nodes to run your containers. So that will be automatically judged by the the ECS. So basically it is a called as a serverless container, basically purely serverless container service, container hosting service, right? In a very layman term, serverless container hosting service is called as a Fargate flavor from ECS. Now then in the default capacity we have base equal to 1, weight equal to 100. So these are all the capacities been defined, and then we need to have the IAM role that is being used in the services, right? So we are creating IAM role called ECS task role. Okay, so remember that so we need to have an IAM role to be assigned while creating the resources of the cluster. Okay, so for that case you see that it has the the ECS role with the basically you see that ECS task will be assuming this one, right? So this role will be trusted by ECS task, the SPN, yeah, or service principal. Okay, so now in the down the line to this role we are attaching a 3 permission, that is DocumentDB full access, ElastiCache full access, and then EC2 task execution full access. Okay, and then this is where we are actually declaring the ECS task definitions. Okay, I'm gonna go down. So this is basically, as you know, that ECS task definition in ECS cluster is nothing but, this is a place where you say that how to run your containers. Yeah, nothing but generally you can call it as a deployment. So how do you define the deployment in the the manifest specification file, right? Or nothing but .yaml file, where in traditional, right, we used to write a .yaml file where we define the kind equal to deployment, then you define the your replicas, then your container definitions will be given, right? That's the same thing, we're going to do it in the ECS task definitions. So here we have a family name, nothing but task name. So I'm generating the task name dynamically. Then the task role, so this is the role which we created above. Execution role is also same. Then the CPU and memory limit is also being defined here, that is nothing but 1024 cycles of CPUs, and we have a 2 GB MB basically memory. And then the network mode is nothing but AWS VPC, because we're going to create a VPC on our own. So it is basically we are telling, hey ECS, I'm going to give you the the VPC infrastructure, try to manage your backend according to that. That's what it's going to do it for us. Then requires the compatibility. This is basically a Fargate runtime. So this is where basically my containers will be running on the Fargate in the Linux environment, right? So this is basically the container container running on the Linux nodes. That's what it means, yeah. And the CPU is basically, the x86 underscore 64 version of CPU architecture. And then this is where basically, we are actually defining the container definitions. Container definition is nothing but it's a list, yeah. In this list, we have a dictionary, something in which dictionary defines certain, key variables. We see what are those key variables. One is the name of your container name, and then the image. Okay, so basically, if you might have seen the manifest file, we will have the the image reference. Okay, so image reference is nothing but it will be referring to a repository. So here our Docker image will be referring. So basically, since we are storing our Docker image in the Docker Hub, so Docker Hub URL will be provided here in the image reference. Here we are actually declaring the CPU and memory that is equivalent to what we have defined in the task. Yeah, and then in the port mapping, nothing but this definition. This task will be listening on a TCP HTTP port. Yeah, and then environmental variable. In the environmental variable, basically on this container, we are setting the environmental variable called database connections, where we are to the database connections, we are actually giving the the connection link to the MongoDB or DocumentDB. In the Redis host, basically we are giving the Redis host endpoint URL. Yeah. So why are we doing? Because with using environmental variable, our application going to reference those the environmental basically our application will consume these environmental variables while it is performing the business logic. Yeah. For example, say it want to do a transaction with respect to the database based on the request. When a request comes, the request will be submitted to the our middle tier, nothing but our application, the worker logic. That worker logic, while it executes, it's going to reference these environmental variable and try to store something on the backend information. That is nothing but database. Yeah. All right. Then we're going to go to the log configuration. So here our log configuration is nothing but we're going to use the AWS logs. That is nothing but our CloudWatch log groups. Okay. All right. So this is what all about. Then we have a CloudWatch log group being referenced here, as I said. And then we are actually creating AWS target groups. That is load balancer target groups are also being created here. You see that this is the name of the target group. HTTPS, it will be listed on the HTTPS. This is VPC. This is the type is IP address. Health check is nothing but this, and the response should be 200 response. So basically, this is a load balancer target group has been created, and then we have a web service service. This is basically heart of the demo, right? So basically, so this is where we are defining that so how my ECS service should be, right? So here we have a ECS service definition given. So it has a cluster on which the service will be listening, and this is the task definition to which the in the sense in front of which task this service going to be created, right? So as you know that in container workload, service is nothing but it's a group of logical pods. The pods is actually hosting the container running in it, right? So basically, if you are grouping a logically grouped containers are basically pods, then that kind of group we are actually calling it a service, and that service object will have a fixed IP address will be assigned to that. Okay, and from there basically the service will be routing the traffic to the backend containers where the actual application will be running. Right, then this is the basically the platform version 1. Then here we have a lot many definitions of the service, that is network configurations. Okay, so basically, as I said, service will be having an IP address. So basically, we are telling, hey, service, you need to get an IP address from this subnets belonging to this security group, and this is the basically the heap. This is the from this VPC you will be assigned one IP address, something like that. And then we need to create a load balancer because this service will be listening to a load balancer. So that load balancer reference will be given here. These are all the the basically on which port the load balancer will be talking, right? That is nothing but this is where the reference will be, right? So you can go down on this source code again. Anyways, don't worry. I'm going to share this code in my video's description, where you can find the GitHub repository link. From there you can get this source code. Anyways, I'm going to make this repository public. Then this is the capacity provider equal to Fargate, base equal to 0, 1, something like that. Yeah, and we have a deployment cluster is nothing but ECS. We have a deployment maximum percentage, blah blah. Lifecycle management, yeah. Then we have a depends on as well. Okay. Then the next stack or the next resource that we are creating is AWS load balancer. So this is our AWS load balancer. It is actually will be created in the same VPC where our cluster is being created. This is where our database will be created. This is where our the cluster service will be created. Okay. So all those options basically in the same VPC we are creating a load balancer, as you see here. So we have a subnet, that is subnet ID AB. So basically, we are actually giving a, hey, these are all the group of subnets in which a load balancer can be created here, okay, like that. Yeah, and then we have a tag, then the AWS, basically you have created a load balancer. Load balancer will have its own listeners. Listener is nothing but, it's a kind of a configuration that you do it on a AWS load balancer. And the load balancer, basically in the listeners will have a property like on which port the load balancer should try to access the service. That is nothing but on port 80. Then what is the type of the, the traffic? That is nothing but forwarding. Yeah, and then target, basically to which it has to target, that is AWS target group. If you go here, that is AWS Fargate target group, right? That's we created above here. If I go down, so this is where load balancer target group we created, right? That is where actually, this LB will be targeting. Yeah, all right. Okay, now next one, that is nothing but basically AWS app auto scaling, right? So even though this is ECS, we also need to explicitly give the auto scaling policy. In the sense, we need to tell AWS ECS that, hey, I want to scale my application pods or application tasks. So generally ECS tells the pods as task. Okay, so how it has to auto scale those tasks. Okay, that is what criteria we need to define in the auto scaling policy. So this is the auto scaling policy. We have a namespace called ECS. Then the scalable definition is equal to desired count. Right, basically, what is the desired count is talking about, in the sense, when you when you deploy the application, you are saying that, byte static, it needs to have this much pod. When certain condition happens, you need to increase the pod number to certain scale. If the condition goes down, then you need to bring it the number of the pods, to back to that. Yeah? So if you see here, the target value equal to 70, scale in cooldown is equal to 300, scale out in the cooldown is equal to basically 300. Yeah, basically in the sense, it can go up to 300. That is what the definition is all about. Yeah, so what is the criteria that it has to consider? That is nothing but ECS service average CPU utilization. Okay, that is the target. Yeah, then the auto scaling target group, right? So you need to basically, you define the auto scaling policy. That policy has to be attached to a auto scaling target group. So here we have a target group that is maximum capacity equal to 3 1. Okay, so basically you are telling that, this is where you need to do up and down. Yeah, that is nothing but it actually points to a cluster, that is ECS cluster, right? You see that this is our cluster name. Within that, we are actually pointing that, the resource ID, in the sense, which resource you want to scale up and down, right? That is nothing but our AWS as ECS service, which we defined above. Yeah, then the desired, the scale dimension is nothing but the desired count, nothing but number of instances. Okay, that is nothing but 3 services it can spin up, like that. Okay, that is about our the main important resource. That is nothing but we now saw how did we define our ECS, how we define our service, how we define our containers, nothing but tasks. Yeah, and now we see how I define the backend information. Then we see how we create a VPC. There are nothing but other 2 component of the infrastructure. Now let's go to the database. So database is as I shown in the design diagram. So we have a 2 backends. That is nothing but one is DocumentDB, which is NoSQL MongoDB version. So, and the other one is the ElastiCache. So first one, we are creating the ElastiCache of serverless version. The engine is Reddish version, right? And this is the name of that DB. Then the daily snapshot is nothing but it's gonna take it at 9 a.m. of every day. This is the Redis cache, and this is the Redis cache engine version. Snapshot limit is, retention limit is only 1. Security group is nothing but it should point to a security group, which I'm going to show you that in a while. Then the subnet in which this DB is been created or hosted will be our VPC subnets. Okay, and then we're going to show the similarly for the DocumentDB, which is nothing but acting as our original NoSQL database storage. So this has the name of the DocumentDB, username, password, and this is the authentication type, right? This is a shards, right? And then the subnet ID, and then the VPC security group. Okay, so basically these are nothing but our the database infrastructure definitions. Now we are done with the 2. Now let's go to the last one, that is nothing but VPC. So as the name says, so VPC will have very simple resources. It will have a ECS, it will have a VPC, AWS underscore VPC, and it will have a subnets and route names, route table and internet gateway, right? Let's see, we see this is our VPC, right? So our VPC is constructed out of this CIDR. We have a subnet one. So you see that subnet underscore A. Why it does that? Annote is basically I'm going to distribute this subnet to a availability zone. Okay, so a region will have its own availability zone. So we are keeping one subnet in a respective availability zone, so that local, regional, the redundancy can be provided, or basically high availability of the zone can be provided there. Yeah. So then we have a subnet B distributed in a West US 2B. Then C is distributed in West US 2C, US West 2C, and then we have a internet gateway created to that VPC. So we need an internet gateway so that our load balancer can talk to the internet. Yeah. And then we have a route table. That is, route table is nothing but we creating a route table with a route targeted to a internet where the source will be go through a gateway. That is nothing but internet gateway. Similarly, if I go to the last resource of the infrastructure, that is security group. As you see here, we have a security group dedicated for MongoDB. So it controls the ingress, that is basically TCP port, and it will talk, it will allow the ingress port on the MongoDB port. So this is for MongoDB, this is for Redis. Okay, so then we have a security group for web server, right? So we have created a basically three security group for controlling the networking inbound traffic on my cluster. Okay, all right. So this is all. You can ignore the environmental file, which I'm gonna delete because we're not using that. You can ignore that. So you might be seeing that, so since we are using the the ECS to host our application, we need to have a package.json file. So this package.json file is nothing but it will talk about how your deployment should be deployed on the ECS. Okay, so for that case, the package.json file information will be very useful, and you need to have this. Okay, so basically that's the reason we have a package.json file. Okay, so I'm not going to walk you through all these options. You can learn it on this one. One information I would like to give you here is you need to change this URL. That is nothing but your repository URL. That is your GitHub repository URL where you have kept your the source code, or this source code. Then we have a workspace, that is app web server workspace, right? And the rest all options are default one. Yeah. All right. So now with that, we're going to go to another very important part of the DevOps repository or DevOps folder. So now we have infrastructure, right? And before I go to the DevOps, the Docker folder, I need to walk you through the web app. So basically, as I said, so this is an example web app, and that is written in the Node.js. So the source code of that Node.js application is sitting in apps folder that is directly underneath my repository. If I can expand this, so we have a root folder called apps. Underneath that, we have a web server. Underneath the web server, we have these many files and folders. So if I so in that one, we have a config file. So these are all the configuration files. So you see that it has a config. Yeah, so in the config, you see that we have a connection to the Redis port. We have a database connection. Okay, yeah, and then we have a config schema. So schema is been given here. You see that it has the database schema connection, database connections, everything schema has been given here. So we have a library. Basically, since we are using the Node.js application, our library will be kept here, right? So I'm not a Node.js developer, but I can walk through the source code for now. So we have a config information present in this config file. We have a library of that, and the other reference files. And you go to the package, basically packages.json file. That is nothing but packages of this the Node.js web application. Okay, so basically this is very simple basic application that is needed for our testing purpose. But in the production, this Node.js application could be doing very big computing job, or a very big business logic can be hosted on this application. It also has a yarn.log file, which I don't know. So basically, and one more thing is you need to know this app.mjs file. So this is where basically this is acting as a kind of controller file, which actually helps you to get the connection to the database and do the basic operations here. Yeah. And so that is considered for now the apps folder that is underneath this repository is nothing but where our source code is sitting. Now, how do I use that a source folder to create a Docker image? So to create a Docker image, we write a file with a name called Docker file, where D is caps, C basically D caps OCKER file, Docker file. So basically, if you give a file name with the name called Docker file, automatically the the compiler of your system or compiler of your IDE will identify that hey, this is a Docker file through which a developer will be creating a Docker image like that. Yeah. So I have this Docker file, and I'm going to walk you through this Docker file now. So here basically this Docker file talks about how this app folder is being used, and being with using that reference, basically source code folder, how I'm creating a machine image. Okay, while creating a machine image, I'm going to incorporate that apps folder, so that whenever somebody creates a virtual machine out of that, automatically the application will be running by default. Yeah, like that. So basically you might be knowing that. So in a layman term, to run an application you need a virtual machine. In the virtual machine or in your laptop, you might need to keep that your source code in a certain folder, and you need to run certain processors, you need to run certain binaries, you need to run prerequisites. Okay, so all those things will be wrapped into a small file, right? And that executable file generally called as a Docker image. And how to build the Docker image will be written in a specification file, right? That is nothing but with using kind of a declarative file, and that declarative file is called as a Docker file. In the Docker file, you see that from this image, from this base image, that is 20-alpine image, you're gonna receive the arguments like ARG stands for, when you are building this image, you're gonna receive the arguments called database connection URI and the Redis host. Okay, nothing but when somebody says Docker build and points to this file, they need to give the arguments for database connection and a Redis host. Okay, so you are going to use those variables and try to, when you are constructing the image, on that image you are creating a two environmental variables with a name like the database connection, the value is database connections, Redis host, so Redis host value has been given here, right? And then if you go to the working directory, so if you see that here we have a working directory. So in this image we are creating a working directory called AWS ECS Fargate. In this one we are actually copying the basically entry script. You see that we have a entry point.sh file, which is nothing but a bash script file. So that file will be copied to this particular path. You see, this is our particular path, and this is the file which we are copying. Yeah, all right. Okay, so then we are actually doing a dot, nothing but you are actually coming back to the original one. Then you are actually installing the certain software that is needed to run the file, that is nothing but needed to run your application, that is yarn install frozen locker file. Then you are actually installing the APK files. Yeah, then the stress ng. Basically these are nothing but you are installing the prerequisite software with running this command called run. Yeah, and then you are actually finally changing this script, the script that you copied from your source code, right? So that is nothing but this this file. So if I open this is nothing but just a bash file, which actually is starting the the server, and then it is waiting for a certain time and it is exiting, something like that it is doing. Yeah, and that is the basically you are making that a script, an executable script. How? By running the bash command, that is chmod plus x, and pointing to this file. Basically you are converting that file into a executable file. Now this application, this Docker build will be the container created out of this Docker image will be listening on port number 3000. That's what the expose is talks about. Then we have an entry point. So the entry point is nothing but the execution of this file. Yeah, all right. So this is very basic application which actually runs this script. Yeah, this is nothing but it starts the script and it will let's see what does it actually do. So this is a where we are actually declaring our Docker file. Now we are done with our backend infrastructure. That is nothing but how I set my infrastructure, how am I constructing the Docker file. Now let's see how I'm creating the infrastructure in the AWS, how we are pushing the Docker image into the Docker Hub. That is very important point now. So let's go to the first one. That is basically first we will see the Docker build. Okay, so how I'm building the Docker image. I have shown a dedicated video, very detailed video on how to create a Docker image and put that Docker image into Docker Hub in a dedicated video. You can watch a previous video on this one. Okay, so basically I'm gonna go very fast here. So this is nothing but a GitHub Action workflow with the name. This is my workflow name. This file will be invoked on dispatch, nothing but manually. And we have a job. So basically we have only one job, and that job name is build-image, and that job will be run on the default runner, that is Ubuntu latest, and this job has these many steps. First one, it will check out the repository, then it actually basically sets the GitHub Action version. You see that it is actually doing the set version in a task here. Then we are actually logging into the Docker Hub. So as I said, we are creating two parameters, that is Docker Hub username and Docker Hub access token. So I have explained these while I walked you through the Docker portal while ago, right? You can watch it again from the starting, so you will understand where we are creating the Docker Hub username and Docker Hub access token. Now where I'm keeping those secrets, right? If I go back to the my repository, that is AWS ECS web service, go to the settings. In the settings, you can go to the secrets and variables, click on actions. In the actions, you have a repository secrets. So here I'm creating the AWS access key ID, access secret, basically AWS secret key. We have a Docker hub access token as we are seeing now, and then we have a Git token, we have a TFC, basically these are all the tokens, yeah. And then we also creating certain variables. So those variable nothing but database connection URI. You can make it as a the secret, but for now I have kept it as a repository variable. Docker hub username, Redis host. Okay, so I'm keeping certain things in the variable, repository variable, certain things in the secret. Okay, so why I'm doing this, so that you understand that how you can reference in the workflow files. Okay, so now with that operations, basically we are having so many things on the GitHub repository settings in the GitHub repository secrets and the variables. So now we have a username in the variable, we have a token in the access secrets. So we are retrieving that and logging into the Docker hub using this the GitHub action endpoint, that is Docker login action 1. Now this is the task where you are actually building the Docker image out of the Docker file. You see, this is very important, that with is basically it's a context of current push equal to true. Then it is referencing the Docker file from this path. If you can open the DevOps file, we have a Docker. In this one we have a Docker file. Okay, and that is what that is what this is doing. And then basically build arguments, as I said, since our Docker file needs two arguments, that is database connection and Redis connection. Okay, so remember that in my case the Docker image is coming next, in the sense running the Docker, not running the build and push Docker image workflow will be run second in my demo. Okay, but I'm walking you through the first. Okay, so here we have a database connection and Redis host. So when you will have these data, that is database connection URL and Redis host. So information of these variables will be available once you run your infrastructure on AWS account. Then your infrastructure will be created, and the references of those infrastructure, like database connection URI, the Redis underscore host will be available from there. Yeah, and so what you are tagging that image, basically I'm tagging that image something like this. Okay, so once this workflow runs, and that's where you see that the image will be pushed here underneath the. So this is the user and this is the repository name, right? So in this repository name, you see the image will be pushed here. Okay, so that is where our we are building the Docker image. Now let me walk you through the infrastructure release pipeline. Okay, so we have a two pipeline. One pipeline releases the infrastructure, the other pipeline releases the Docker hub, right? When you releases the infrastructure, basically that's where you are creating the ECS, you are creating the services, you are creating the tasks, right? You are creating the ALB, VPC, everything will be created in a apply.yaml file, nothing but our infrastructure file. Yeah, so the name of this file I have given is ECS stack-apply, and this will be invoked on by manually, that is workflow dispatch. We have a jobs, it will be running on a default runner. Basically default run is equal to shell. Yeah, similarly it has steps like checkout steps, and here we are using the Terraform setup. So here, as I said, we are using the TFC, so we need to give the CLI config credentials. So this is the CLI config credential, nothing but our TFC API token, which I set it as a secret, and that is being referenced here. So this task will actually create you basically a connection to the TFC workspace, and it will try to execute the all Terraform file compilation and run remotely. Right now, next we have a natural Terraform command, that is nothing but Terraform init, Terraform validate, Terraform plan, and Terraform apply. Right. So once the Terraform apply is done, basically your infrastructure is done. Once the infrastructure is provisioned, you will have the output. In the output, you will have a DocumentDB connection URI. Then you will have the ElastiCache hostname. You will have the ALB information. Okay. So likewise, I have the one more workflow, that is workflow file, that is plan.yaml file. Okay. Now I have made you to walk through the complete source code. Now we go to the next part of the demo, that is nothing but showing you the right real-time execution. Okay, so for that case, I will take you to my repository, that is nothing but again basically again my GitHub repository. And in this one, we will first invoke or first release our ECS stack apply. As I said, ECS stack apply is the first task you need to run so that your infrastructure is ready in the AWS account. and then you can do a build and push. Then only that your ECS task will reference the image from the Docker Hub and spins up the task executions. So for that sake, I'm gonna run this ECS stack-apply workflow file. So once you start this one, so basically this is how it looks. I'm gonna show you the live demo. Basically, as you see that currently it is deploying the stack as you show here. Basically, it is setting the Terraform, doing the init, right, and it is trying to validate it, doing the Terraform plan. Note that I have already spinned up my infrastructure, and for that case it will show no difference and it will continue to the next step, right? But in your case it might take nearby 30 to 40 minutes. Okay, remember that creation of DocumentDB, it will take nearby 15 to 20 minutes, so you need to be very patientful, right? And creation of ECS task will also take 5 to 10 minutes. So in total, for the first time, deployment of the stack will take nearby 35 to 40 minutes. Yeah. So then I'm going to show, here you go, right? So you see that infrastructure is matching, right? Now it is doing a Terraform apply. So it will not do anything. So we will see a couple of seconds, right? So basically it will do the same thing which you have seen in the Terraform apply. Yeah. So what are we doing here, right? So basically with using the GitHub Actions, we're actually spinning up this infrastructure. Yeah. And then we are seeing the, the basically end to end. Yeah. So this is basically, zero to hero kind of thing. Okay. So I'm showing you everything that you need to know. Alright, so and here we are doing a production grade management of your infrastructure, production grade, creating the container application, basically containerizing your application, then pushing that image into a Docker Hub, which is enterprise grade image storage, and then from there, you are actually referencing the, that image in your application in the ECS task. Okay, so here you see that the deployment is green, which means that our infrastructure is ready. If I go to my AWS account, so this is my AWS account. We were creating the the infra, that is ECS in the Oregon region or US West one. You see that here you go, right? So here we have a cluster name. This is my cluster name. In this cluster name, I have a service that is AWS ECS CQPL, that is cloudquicklabs web service. This is one service, and currently the task is running. So we're gonna see that. Okay, so if I go down, if you open this one, it will have a one task, that is nothing but this is a task. Currently it is also running. Yeah. And if you open this task, you're gonna see that from where it is, whether it is running or not, what is the problem, like that. Yeah. Okay, so now we're gonna go to the another workflow file, that is build and push. Okay, so for that case, again, let's run this build and push. Okay, so I'm gonna quickly run this workflow so that you get a full confidence. Now we are actually running this build and push Docker image. Yeah? So I'm gonna do that. So here it will take a very couple of minutes. So if I go to the Docker Hub while it is running, you see that it is pushed 3 hours back. Now the date has to be refreshed. Why? Because it is pushing the latest image. If you go here, if I go up, so currently it is login is successful. If I expand this, login is basically successful. You see login is succeeded. Currently it is building, and it is very fast. It has pushed the image as well. You see that it is actually image is pushed, that is post. Basically it was very quick, right? So you see that it is like a lightning one. Okay, so it has pushed the image. Now if you go to the Docker Hub, and if you see the refresh, let me see if it replicates something here. You see that our image that is tagged as latest image, which is Linux version, and it has been pushed recently. Okay, now when it is pushed recently, we should see the changes here. If the image reference is same, the cluster may not do anything. So let's see what is it happening. If I refresh it here, so basically we already have the task running. You see that task is already running, and so you don't need. So basically, once the image version is matching, so the ECS cluster will not reference the image again and again and try to pull it. It will remain in the same stage. Okay, so until the reference, in the sense, make sure that let me tell you something, right? So here, make sure that you tag the image every time with a new value. Right? So once you tag the image with every time with a unique tag ID, you need to dynamically reference that unique tag in the cluster, and then only every time the new image gets pushed into Docker Hub, ECS will extract that image and try to create a container out of it. Okay, so that is nothing but that kind of dynamic capability is provided by the ECS. All right, so for now we're gonna walk as it is. So basically, if I open the this ECS service, you see that it is basically application. So basically it has a load balancer, that is nothing but this load balancer. If I click on this load balancer, it will take us to the particular, so that is nothing but the target group. So we have a target group. That target group has the load balancer. So if you click on a load balancer, it will take you to the load balancer, nothing but the application load balancer. If you click on this application load balancer, you will get an endpoint. The endpoint of the the load balancer will be available somewhere here. If you see here, this is our DNS. Yeah. Okay. All right. So this is the load balancer which is available on the port number 80 only. Yeah. Okay. So before that, let's go to the another infrastructure, that is our backend information. Okay. So our backend infrastructure is nothing but a DocumentDB. So we have a DocumentDB which is running fine here, right? And you see that this is where the connection ID will happen. Okay. So for that case, I was about to tell you. So if I go to the settings, and go to the basically secrets, in the secrets we have a secret called basically variable called Docker connections. Okay, that is nothing but database connection. So that database connection should be something like this. Okay, you can copy this one and change the value of your password here, and that value should be kept it here, that is in the variable, and then only you need to run the Docker build. Okay. All right. Then that is all about our the MongoDB cluster. This is the configurations you can do. This is the monitoring also, you can do it as it here. Yeah. All right. So now I will take you to the another resource, that is nothing but our ElastiCache. Okay. So an application definitely need to have a cache so that it can avoid the the traffic, or it can avoid the transaction on the database. Okay. So that's the reason we use Redis cache for in-memory caching purpose. Yeah. And it has a backup and event are also been configuration. Okay. So with this with this all configuration, our application is now ready to be tested. Okay. So now let's go here, that is either phone or laptop. We're going to run this ALB and check our task will be responding something or not. Okay. So for that case, let me go and try to access our endpoint. So what is our endpoint? You see that the listener rules, we have a network mapping. So this is network folder. Okay. So let's go back to the load balancer. So this load balancer, if you see here, this is the details. You have VPC. So it will be available on the on this particular load balancer. Let me copy this, and let's access this load balancer over HTTP. Okay. So if you see HTTP : and put this